So in this tutorial, we're going to look at a way for designing a scene like this, where we have blood flow and the camera that is seemingly following along with it. You can use this if you want to focus on the structure of a white blood cell or something else that's floating in the blood flow. But the difference to what we're doing here is we're actually not moving the blood particles along the curve and moving the camera with them. Instead, they're staying static and just moving around a local position, but moving the texture of the wall of the capillary to make it seem like it's receding away from us or we're moving along. So just a different approach to doing something pretty simple, but can be useful in some cases. So it'll allow us to look at things like the texture deformer, bringing in and offsetting textures from After Effects, and combining these with Mesh. So let's just hide this, and we'll go back into Maya. So here's the scene here, so we can just play this and you can see what's going on. There's a little pop there because this is using dynamics in Mesh to avoid these cells from bumping into each other, to passing through each other. But if we look from the top here, we can see that the camera is actually located here, and if we play the animation, it's not moving, but you can see the texture along the surface of the capillary wall is moving. So that's using the texture deformer, and you can see the red blood cells just moving in place here around they're on the curve, but they're moving in a local position. So let's just recreate this here. So create a new file. And to do this, there are a few things we have to set up. First, we're going to need a curve. And I'll do this in the top view. So let me turn off my heads-up display here. And then a cylinder that we will use to deform along this curve. So just increase its height to kind of match the length of the curve. It doesn't have to be exact because the curve warp deformer will fix that for us. We don't need the top or bottom faces, so we'll just delete the cap faces here. Actually, sorry, I'm going to go back, and we actually need more resolution than this. So we could do this before the fact or after. I'll just add some resolution here. That's because we're using the texture deformer and it needs faces and vertices to push around. Probably still have to smooth this actually. Right, so now I'm just going to smooth this once. Okay, so that's probably pretty good. And now I just want to clean up the UVs a little bit. So if I go into the UV editor here, we can see we have all our UVs. Just double click on them. And now I just wanted to fit it into the 0 to 1 UV space. So here in the UV toolkit, we can go down here and just click on Layout in U and in V. I thought that would do the whole thing. Okay, I take that back. So we'll just have to scale this up. And we want this to fit in the 0 to 1 UV space. Don't want to go outside of it. It's funny. Okay. All right, so we might not get an exact seam here, but that looks pretty good. So we'll just delete the history on this thing now. And freeze its transformation, select the curve, and go to Deform Curve Warp. So that's good. So here's our little capillary, and we're going to be looking inside the model, so we have to reverse the surface normals too. So just select the mesh and go to Mesh Display and reverse. Right. And it will deform properly too. So now what we're going to use is the texture deformer to deform the actual surface, and that's why we need so many subdivisions here. And we could use any kind of texture to do this. If we go into Maya, you could use one of these textures here. You could probably use something like bulge if it was deformed somehow. I think there is a way to deform bulge. But anyway, what I tend to use is After Effects to generate a cell pattern texture. So here you can see what we're trying to create. I'll just create a new one here. So just create a new solid. I'm going to make a 4000 by 4000 pixel texture here. Now, it doesn't have to be that big, kind of depends on your needs. But we need to know that number, and it should be square. So I'm just going to right click on here, go to Effect, Cell Pattern, which can be found under Generate Cell Pattern. And so it does, oops, I'm not in Maya anymore, so it does what you'd imagine. And we have to go into the effects here and make sure Enable Tiling is turned on. And then we can change the number of cells horizontal and vertical. And to make sure that it will tile properly, the size or the number of cells horizontal and vertical multiplied by the size of the cell should add up to the size of the texture, which remember is 4000 by 4000. So 4 here times, we have to change the size to 1000 to make sure this will tile. If we don't want it that big, we could change this to 500, but then we'd have to change these to 8 and 8 to get the 4000 again. I'm going to make, I think, stick to the 1000 size and go back to 4. But just so you know, that's how I understand how it works anyway. I've got these guides here because I'm just checking to make sure these edges line up. So where it meets the edge here, it should meet the edge over here, the division between the cells. So that looks right. That looks right. That looks right. I think this is working. There's an edge that comes down here and it meets an edge here. Oops. Just going to turn up the contrast a bit so we can see a little more clearly. Now, we don't want to turn the contrast up too much because we'll get these spaces in between here, but just for now. Yeah, so you can see this little bulge here matches this. This little part here should match. Yeah, so this edge here. So yeah, that all works. It's going to reduce the contrast a bit. So it's these black and white values that will determine the deformation of our surface. So just want to get it the way we like. So we'll go now to Composition, Save Frame as a file. And we'll save this out as a TIFF. It says TIFF sequence, but we're just doing one frame. And then I'll just name this cell pattern 4. And then click on Render. It's done. So now we are going to add a texture deformer to this. And hopefully this will work. So deform texture. Now we can map something to the texture attribute here. So we're going to click on the checkerboard and then choose a file node. And then we can navigate to that file that we just created, cell pattern 4. Right? And so it does something, which is good. It looks kind of a little weird, but now we can change the strength so it's not quite so strong. And so it may be that we need actually more subdivisions in this to make it work, because it actually needs the right number of vertices to actually approximate these deformations. And you can see mine is actually a little low res for this, so you might actually want to have a higher resolution than this. But anyway, we'll work with this because we're going to change some of the qualities anyway, but you may have to modify yours based on your needs. Okay, so let's say I'm in here like this. Now if I go into the file node here, so I can change things here, but we can also change things in the place 2D texture node. And so here we can repeat the texture, and because it's tileable, we should be able to do this seamlessly. So we want to repeat it in V, maybe more than once. Okay, maybe not V, maybe we want to do it in U. Yeah, so that's along the curve here. So if I do it more, then we'll see more repetitions of this. And if we want to, we can have more repetitions around like this. And this all seems to work pretty well. So we can pretend this is not really a capillary, but something like a high endothelial venule in a lymph node or something, where you've got these this very sort of rugged terrain inside the vessel. Okay, so that's all good. So now if we want to animate this, we also do this in the place 2D texture node, and we use this, do this in the offset. So if we just hold down Control, middle mouse. Okay. Not working for some reason. Okay, here we go. So you can see when I animate offset U, I'm just using the virtual slider here, we can animate it moving away from us or towards us. So we can just set a keyframes here, or we can just write a simple expression. So I'll just Control right click and say, copy this attribute, and this will equal, so if I say time, semicolon, it'll probably be very fast and maybe in the wrong direction. Oh, it's the correct direction. Maybe a little too fast, so I can multiply this by decimal. Maya always prefers multiplying rather than dividing, so if we do that, click on Edit, and then Play. So if I just move out here, you can see what's happening. It's just offsetting that texture along here. And so from the camera's point of view, it looks like we are traveling along this thing. So if I just deselect this, it might be easier to see. Now, the one thing I didn't do in my previous example is I didn't animate this curve at all, but you could animate this curve if you wanted to. And you could do this in a number of ways. You could even make it a dynamic curve, or you could rig it or something. You could rig the whole tube if you want to, but it would be better to deform the curve because then whatever mesh object you put on the curve will follow it. But if I select this curve, for example, and go to Control Vertices, and then select them all. Oops. Just going to hide this for a second. Just make clusters out of these. Now if I take this cluster back here, for example, and move this up and down, you can see that the vessel will also deform. So I'm just going to set a really slow animation on this. So I'll just maybe key this here, and then over many frames, 120 frames, key this going down like that. So then we can kind of get an idea. So just this is actually making me slightly nauseous, but you can get an idea that you can make it look like the path is turning in a more complex way. And let me just create a new camera. Let's look through this camera and just set it up. Is this the correct end? No, let's do this end here. So it's traveling in the right direction. So something like this, and I'll just lock this camera down. Just turn on its resolution gate. So now if we play, right, we can get something interesting like that. So now the next thing to do is to add the blood cells, or probably best idea is to save. Before we go ahead. And so let's get into our perspective camera. So we need a blood cell. I'll just create something quick here. Just a cube. Just smooth this. Oops. Okay, nothing fancy here. Maybe I'll just smooth it one more time. Make it a bit smaller. Okay, so let's just pretend that looks good. And we will call this RBC. And always with stuff that's going to form the basis of a MASH network, deletes history and freezes transformations if you don't need the history anymore. Okay, so now we'll just quickly do something we've seen many times already. Create a MASH network. Now this can be an instancer or a MASH. I'll just do an instancer for now. And then we'll go into MASH and we'll add a curve node. Right, so now we have to add the curve that we are using. Now they, like normal, things look weird, but remember we still have the MASH distribute that has an offset in a distance of x by default. And let me just hide this thing for a moment. So now we can go into the MASH curve node and then increase the step all the way to 1, so it will go along the curve. Now if we play the animation now, it's actually animating along the curve. We don't want that in this case, so we turn the animation speed to 0 so it doesn't move, but it sticks to the curve. Now we want more of these things. Okay, so let's say 50 for now, and then we have to add a random node so that they have to fit within the vessel. And we're actually going to add a signal node too, which will add animated randomness. So we just have to make sure everything is good and that we can randomize the rotation too. Let's just unhide our cylinder, see if it all fits. Okay, that's pretty good. Now we are also going to add a signal node to give it some animation. And we can play this and just see. All right, so it's moving too much. The signal is animating the position in X, Y, and Z, and Y it's going all the way up to 5. So we'll just reduce this to a smaller amount. And again, this will vary depending on the nature of your scene. Right, and that might be too fast, so there's a time scale here down in the signal node, and I can reduce this to 0.5 to slow them down. Right, so okay, that's fine. And the good thing about MASH, of course, is if you then decide, think, okay, there are just too many of them, you just reduce the number in the distribute node, and then everything else still works. It's much easier than trying to use something like particles. Okay, almost there. So now the last thing I'm going to do, well, I'm going to save because this is crashy, and we're going to make these things dynamic. So MASH dynamic. And we want to, in the dynamic node under MASH bias, make sure the position strength is all the way up. So this means MASH is still controlling the position, but the dynamics will just keep them from passing through each other. Oops, don't play backwards. And you may want to add some bias towards mesh in the rotational strength, so the signal node can still animate the rotation, which I don't think I set up. So if I go back into the signal node, you can have it animate the rotation a little bit too. Right, so however you want this. Okay, and then of course you can put a texture, shader, whatever you want on here. You can do the same thing for your mesh object. But the last thing I would recommend doing is to cache the mesh object. And the reason for that is for rendering, you want to have a consistent dynamic simulation. And if you don't cache it, you will get different values each time you render. Or if it crashes on render 110, and then you want to start up on render 111, they're not going to match up anymore because it will start up from the wrong spot. So it's always a good practice to, in the mesh network here, so I'm in the waiter node here. Under caching, we can open the cache creator here. And we want to create a cache for position and rotation. And of course, this has to, you have to make sure you have the project set so it knows where to save these, and then Maya can later find these files. And so we'll just do it for 120 frames. We'll create cache and we'll just play through. This is just for the mesh. It's not for the rest of the scene. Actually, I don't think I was on play every frame. I'm going to go back and do that again. I'm going to delete the caches, turn on dynamics, create a cache again. It probably worked the first time, but because I was on playing in real time, it might have skipped some frames. So when it finishes, it will turn off the dynamics here. And if we go into the mesh waiter, you can see position and rotation cache are enabled. So now if we look through our other camera and we play the scene, then we get blood flow without moving the blood at all. Anyway, this is again an old technique that offsetting a texture to make it look like something surrounding the camera is moving is an old technique. But in this case, it actually works in an interesting kind of useful way. And you don't have to model a really long capillary or animate the camera following along blood cells to try and focus on one or another. So hopefully this can be useful to you in some situation. Thanks.